Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today, I will explain the differences between HarmonyOS and AndroidOS based on several aspects such as architecture, ecosystem, performance, target devices, adoption, and development tools. First, in terms of architecture and kernel, HarmonyOS uses a distributed microkernel which allow devices to work together and communicate smoothly. It is designed mainly for cross-device interaction. On the other hand, Android uses a monolithic Linux-based kernel. It focuses more on performance within a single device like smartphone. Next is ecosystem and connectivity. HarmonyOS provides a super device experience where devices can share resources easily and connect natively with each other. Meanwhile, Android depends heavily on Google Play services and third-party integration to enable connectivity between devices and applications. For performance and efficiency, HarmonyOS is lightweight and fast, and it can run smoothly even on low-spec devices such as smartwatches. Android is more resource-intensive, but it delivers strong performance, especially on smartphones. Looking at target devices, HarmonyOS is built for a multi-device ecosystem, including LOT and smart environments. Android mainly focuses on smartphones and tablets, although it is also used in TVs and cars. In terms of adoption and openness, HarmonyOS currently has a growing ecosystem, mainly within Huawei devices and limited global usage. Android is widely adopted worldwide and supported by many manufacturers. Finally, development tools and application. HarmonyOS supports unified application across multiple devices using distributed apps. Meanwhile, Android provides mature SDK tools and a huge app library, making it very developer friendly. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Today I will present about HarmonyOS versus Android device connection handling. First is HarmonyOS is a distributed operating system that developed by Huawei. Unlike traditional operating system that focus on the single device, HarmonyOS works across many types of devices such as smartphone, smart TV, wearables, vehicles, and IoT devices. It forms what Huawei calls a super device, allowing this device to work together as one ecosystem. This means that the data and the service can move seamlessly between the device, making cross-device interaction smooth and efficient. HarmonyOS handles devices connection differently from Android. In Android, each device is a self-contained. Apps run locally and devices rarely interact automatically. HarmonyOS, however, treats multiple devices as a part of a single ecosystem. Devices can share resources like screens, cameras, speaker, and sensor. For example, you can project your phone screen into the TV, use your smartwatch health sensor directly through your phone, or borrow your laptop camera or internet connection from your mobile device. All of these work seamlessly without installing extra apps or performing complicated setup. This makes using multiple devices together much easier and more intuitive. Next is we want to focus on the architecture and the benefit. The main difference comes from the system architecture. Android uses a traditional monolithic app model. Apps runs mainly on the local devices and the device handle most processing and storage. HarmonyOS use a distributed architecture, which means processing, storage, and app logic can be shared across multiple devices or cloud servers. This allows HarmonyOS to optimize performance, handle heavier tasks, and extend battery life. It is microkernel design also ensure secure communication between the devices. In short, HarmonyOS benefit is enabled seamlessly across device collaboration, better performance, longer battery life, and smarter use of device resources.
For this part, I will explain HarmonyOS from a developer's perspective based on our findings. HarmonyOS provides a unique experience mainly because of its distributed architecture and multi-device support. Unlike Android, which is mostly optimized for individual devices, HarmonyOS is designed to allow applications to run across multiple devices within the same ecosystem. From a developer's point of view, this means an application does not only run on one device, but can interact with other devices such as tablets, smartwatches, and smart TVs. One important feature is resource sharing, where developers can design applications that share resources like screens, cameras, and speakers across devices. This clearly reflects the concept of a distributed operating system, which we study in this course, where multiple devices work together as a single logical system. Another advantage is the microkernel based architecture used by HarmonyOS. Since fewer components run in kernel space, the system becomes more secure and stable, and the risk of system failure is reduced. This is especially important for developers who are building applications for smart devices and IoT environments. In addition, HarmonyOS is optimized to run on devices with lower hardware specifications, which makes it suitable for wearables and smart appliances. From a developer's perspective, this allows applications to be developed for a wider range of devices using a more lightweight operating system. However, based on our findings, HarmonyOS also presents several challenges for developers. One major challenge is its smaller application ecosystem compared to Android. Android has a very large and mature ecosystem, while HarmonyOS currently has fewer applications and limited third party libraries. Because of this, developers may need to rely more heavily on Huawei provided tools and services, which can reduce flexibility during development. Developers who are already familiar with Android may also find it challenging to adapt as Harmony OS does not fully follow Android system, methods, and application structure. Another challenge is the learning curve. HarmonyOS requires developers to understand the new concepts such as distributed applications and cross device interaction. Developers need to learn how tasks and processes are coordinated across multiple devices instead of running on a single device only, which adds complexity. In terms of development tools, HarmonyOS uses DevEco Studio, which supports distributed UI development and multi device testing. These tools are designed to match Harmony OS's system architecture, but they are still less mature compared to Android Studio. Overall, based on our findings, Harmony OS offers strong potential for future distributed system and multi-device environments, but developers may still face challenges due to its limited ecosystem and higher learning curve.
Assalamualaikum and hi, my name is Shafika binti Suhaimi. Today, I will discuss about Android from developers' perspective. To provide a balanced comparison between Android and Harmony OS, this section focuses on Android from a developer's perspective, particularly in terms of development environment, ecosystem support, system stability, and long-term limitations. Android provides a well-established and stable development environment that has been refined over many years. As one of the most widely used mobile operating systems in the world, Android benefits from extensive industry experience and continuous improvement. For developers, this means working within a platform that is predictable, well documented, and supported by mature development practices. One of Android's most significant strengths is its large global market size. Android devices are used across different regions, price ranges, and manufacturers, from entry level smartphones to high end flagship devices. This wide adoption allows developers to reach a diverse and massive user base, increasing the potential visibility and impact of their applications. From a commercial perspective, this makes Android an attractive platform for application deployment and monetization. In addition to market reach, Android offers a rich ecosystem of development libraries and frameworks. These resources support various aspects of application development, such as user interface design, background processing, data storage, networking, and security. Developers can also integrate third party libraries to further enhance application functionality. Along with these libraries, Android Studio provides a comprehensive development environment that supports coding, debugging, testing, and performance optimization, enabling developers to work more efficiently and systematically. Another important advantage of Android is its large and active developer community. Due to its long presence in the market, Android has accumulated extensive community driven knowledge. Developers can easily find tutorials, discussion forums, sample projects, and troubleshooting guides online. This strong community support reduces the learning curve for new developers and helps experienced developers resolve complex issues more quickly, improving overall development productivity. From a system architecture perspective, Android is built on a Linux based kernel, which contributes to its reliability, security, and flexibility. This foundation allows Android to support a wide variety of hardware configurations, including smartphones, tablets, wearables, and other smart devices. Although Android faces challenges related to device fragmentation, such as different screen designs, such as different screen sizes, hardware capabilities, and OS versions, Google provides compatibility guidelines, APIs, and testing tools to help developers maintain consistent application behavior across devices. Despite these strengths, Android has notable limitations when compared with Harmony OS. Android's development model remains largely centered on a single device's applications. While Android does support cross-device features such as cloud synchronization and device connectivity, these capabilities are often implemented at the application level or rely on third-party services. As a result, cross-device interaction is not deeply integrated into the operating system itself. Based on the findings and analysis discussed, our group concludes that while Android remains highly competitive due to its ecosystem maturity, system stability, community support, and market reach, HarmonyOS offers greater long-term value for developers. Its distributed architecture introduces a new development paradigm that aligns more closely with the future of smart ecosystem and interconnected devices. In conclusion, Android continues to be a strong and reliable platform for conventional mobile application development. However, for developers who aim to build next generation multi-device and distributed applications, HarmonyOS is considered the more suitable operating system for future system design and emerging smart environments.